Imagine standing beside a machine so enormous that it seems impossible for it to leave the ground. A modern passenger airplane can weigh more than 400 tons when fully loaded. That's heavier than hundreds of cars combined. Its wings stretch wider than many buildings. Its engines are taller than an average person, and every part of it is built with incredible precision. Now imagine this giant machine beginning its journey. The engines roar to life. The aircraft starts rolling. It gathers speed, faster and faster, until it's racing down the runway at nearly 300 kilometers per hour. Then something extraordinary happens. The wheels leave the ground. Within seconds, a machine weighing hundreds of thousands of kilograms is climbing effortlessly into the sky. At first glance, it almost looks like magic. But there's no magic involved. Every successful flight is the result of some of the most brilliant engineering and physics ever developed by humans. Every single day, more than 100,000 flights take off around the world. They carry millions of passengers across mountains, deserts, oceans, and entire continents. For most people, flying has become so common that they hardly think about what is actually happening outside the window. But have you ever stopped and asked yourself one simple question? How can something so incredibly heavy stay in the air? Gravity never takes a break. Every second, it is pulling the airplane back toward the Earth. Yet the aircraft continues climbing higher and higher until it reaches an altitude of nearly 35,000 feet, where it can travel thousands of kilometers without falling. So what is the secret? Is it the powerful engines? Is it the enormous wings? Or is there something happening that most passengers never notice? The answer is far more fascinating than you might expect. An airplane doesn't fly because it defeats gravity. It flies because every force acting on it is carefully controlled and perfectly balanced. Every curve of the wing, every movement of the engine, and every adjustment made by the pilots works together with incredible precision. In today's episode of The Hidden Process, we're going inside one of humanity's greatest engineering achievements to uncover the hidden science that allows these massive machines to rise into the sky, remain stable for hours, and safely return to the ground. Once you understand what's really happening, you'll never look at an airplane the same way again. To understand how an airplane flies, we first need to face something that seems obvious. If you take a heavy object and drop it, it falls immediately. Gravity pulls everything toward the Earth. A stone, a car, a building, even a human being, all of them are affected by the same force. So logically, a machine that weighs hundreds of tons should behave the same way. It should fall, but it doesn't. Instead, it moves forward and somehow stays in the air. This is where most people misunderstand flight. Airplanes are not fighting gravity directly. Instead, they are constantly managing four invisible forces that act on every flying object. These four forces are lift, weight, thrust, and drag. Every second of every flight is a balance between them. Weight is simple. It is the force of gravity pulling the airplane downward. Drag is the resistance of air pushing against the aircraft as it moves forward, like an invisible wall slowing it down. Thrust is the forward force created by the engines, pushing the aircraft ahead at incredible speed. And then there is the most important force of all, lift. Lift is what allows the airplane to rise into the sky. Without lift, no aircraft in history could ever leave the ground, no matter how powerful its engines are. But here is the interesting part. Lift does not come from engines. It comes from the shape and movement of air itself. This is where physics becomes fascinating. As the airplane moves forward, air flows around its wings. But the wing is not flat like a simple board. It is carefully shaped, curved on top and flatter on the bottom. This shape changes the way air moves. And when air behaves differently above and below the wing, something powerful happens. A force is created. A force strong enough to lift hundreds of tons into the sky. But how exactly does this happen? Why does air move differently over a curved surface? And how can something invisible create enough power to overcome gravity? To understand that, we need to go deeper into what is happening at the edge of the wing, where air is being split, accelerated, and transformed into one of the most important forces in aviation. And that is where the real secret of flight begins. Stand beside the wing of a passenger airplane, and at first glance it doesn't look very special. It's just a long piece of metal. But hidden inside its shape is one of the greatest engineering discoveries in history. This shape is called an airfoil. It has a gently curved upper surface and a flatter lower surface. That small difference changes everything. As the airplane accelerates, millions of tiny air molecules rush toward the wing every second. The wing slices through the air, forcing the airflow to split into two paths. One stream flows over the top. The other flows underneath. Because the top of the wing is curved, the air above it speeds up as it travels across the surface. The air below moves differently, creating a pressure difference between the two sides of the wing. Higher pressure forms beneath the wing. Lower pressure forms above it. And nature always tries to balance pressure. The result is an upward force called lift. This invisible force pushes the wing upward every single second the airplane is moving through the air. It sounds almost unbelievable. The air around us, something we can't even see, is strong enough to lift an aircraft weighing hundreds of tons. But here's something even more surprising. Many people are told that lift happens only because the air on top has to travel farther and meet up with the air underneath at the back of the wing. That explanation is popular, but it isn't completely correct. In reality, the air flowing over the top usually reaches the back before the air underneath. The real reason is more complex. The wing bends and redirects the airflow downward. According to Newton's third law of motion, every action has an equal and opposite reaction. If the wing pushes air downward, the air pushes the wing upward. That upward reaction works together with the pressure difference to generate the lift needed for flight. So lift isn't created by one simple idea. It's the result of carefully designed wing shapes, pressure changes, airflow, and the laws of physics all working together. Every commercial aircraft in the world depends on this balance. Without it, even the most powerful engines would never get an airplane into the sky. But creating lift alone isn't enough. The airplane still needs enough speed for that lift to become stronger than gravity. And that's where the engines take over. Imagine trying to push a fully loaded passenger airplane with your hands. Impossible. Even the strongest machine on Earth couldn't simply shove a 400-ton aircraft down a runway. So where does all that power come from? The answer is hidden inside one of the greatest machines ever built, the jet engine. At first glance, it looks like a giant metal tube hanging beneath the wing. But inside, thousands of precision-engineered components work together at incredible speeds. The process begins the moment the engine starts. A giant fan at the front begins spinning. It isn't just for show. This fan pulls an enormous amount of air into the engine every second. In fact, a large commercial jet engine can draw in more than 1 ton of air every second during takeoff. The incoming air then enters a series of powerful compressors. These rotating blades squeeze the air into a much smaller space. When air is compressed, its pressure rises, and so does its temperature. Next, the compressed air enters the combustion chamber. Here, aviation fuel is sprayed into the hot, high-pressure air. An electric igniter starts the process, and once the flame is established, it burns continuously while the engine is running. The temperature inside this chamber can exceed 2,000 degrees Celsius, hotter than lava, and even hotter than the melting point of many metals. So why doesn't the engine melt? Because engineers designed an incredible cooling system. Tiny holes in the turbine blades allow cooler air to flow through them, protecting the metal from extreme heat. After combustion, the hot gases expand rapidly and rush toward the back of the engine. As they pass through the turbine, they spin another set of blades. These turbines are connected by a shaft to the compressors and the giant fan at the front, keeping the entire engine running in one continuous cycle. Finally, the exhaust gases blast out of the rear of the engine at tremendous speed. According to Newton's third law, if the engine pushes hot gases backward, an equal and opposite force pushes the airplane forward. That forward force is called thrust. Without thrust, the airplane would never gain enough speed to generate lift. Together, the engines and wings perform a perfectly coordinated dance. One creates forward motion. The other transforms that motion into flight. But even with powerful engines and perfectly designed wings, there's still one critical moment every pilot must master. The moment when the airplane finally leaves the runway. The engines are now producing maximum thrust, and the aircraft races down the runway. As the speed reaches the carefully calculated rotation speed, the pilots gently pull back on the controls. The nose rises, the wings generate enough lift, and within seconds, a machine weighing hundreds of tons leaves the ground. From that moment, the airplane is no longer supported by its wheels, but entirely by the invisible forces of the air. As the aircraft climbs to its cruising altitude of nearly 35,000 feet, it travels at almost 900 kilometers per hour. Yet despite the incredible speed, every movement remains smooth and controlled. Tiny movable surfaces on the wings and tail constantly adjust the aircraft's direction. Ailerons roll the airplane into turns. Elevators raise or lower the nose, and the rudder keeps the aircraft perfectly aligned. Much of this is assisted by sophisticated autopilot computers, which continuously monitor altitude, speed, and navigation, making thousands of tiny corrections every hour. Even when the aircraft encounters turbulence, its flexible wings and advanced engineering are designed to absorb the forces safely, which is why turbulence is usually uncomfortable, but not dangerous. Eventually, every flight reaches its destination. As the aircraft begins its descent, the pilots carefully reduce speed and extend the flaps, increasing lift while allowing the airplane to fly safely at slower speeds. Moments later, the landing gear locks into place. With remarkable precision, the aircraft touches down gently on the runway. Immediately, spoilers rise from the wings to eliminate lift, while reverse thrust redirects the engine's power forward. Powerful carbon brakes complete the job, bringing hundreds of tons of aircraft safely to a stop. From takeoff to landing, every second of the journey depends on the perfect combination of physics, engineering, advanced computers, and highly trained pilots. The next time you look up and see an airplane crossing the sky, remember, you're not just watching a machine. You're witnessing one of humanity's greatest engineering achievements. This is exactly what the hidden process is all about. Every machine around us hides an incredible story waiting to be discovered. If you enjoyed uncovering the science behind flight, subscribe to The Hidden Process, because in our next episode, we'll reveal another extraordinary engineering mystery. Until then, stay curious, because every machine has a story, and every story has a hidden process.